I don't want my video cut out, but make a Venn diagram to display the sample space. So here's what we're doing. You got two events. You got the event of graduating, you got the event of owning a home. So putting all of this in there. How many overlap graduate and home ownership? So you got graduate and home ownership, there's your overlap. So that goes in the middle. That's your intersection. How many total people graduated? 310 if you total those up. So this circle needs to total to 310. There are 89 that graduated that do not own a home. So that's how that would look. This goes here. There's 310 total. How many people own a home that did not graduate? 119. And then if you subtract that, how many people did not graduate and did not own a home? 71. So that's how that's displayed. As this. This is your Venn diagram for G and H. So try to make sense of those numbers in there. Find the probability of G or H. Explain why that does not equal G plus H. Then find G or H. So this happens in the event that these are mutually exclusive, that there's no overlap. This happens if there's no overlap. Is there overlap here? Yes, there is. So explain why this is not going to happen. This will not happen because there is overlap. And so to find this right here, you have to do that plus that minus the overlap. Like that. This is the formula we would use to find the union. Now you could just use the Venn diagram, which is fine too. So the probability of graduating was 310 out of 500. Probability of home ownership was 340 out of 500. Probability of the intersection was this 221 out of 500, which leaves you with 429 out of 500, 0.858. Alright, or we could have just added these up, because again, this is the union. So there's lots of ways to display math. There's lots of ways to display statistics. We can display statistics analytically with a formula. We could use a picture, like a Venn diagram. So if I add up these, I will get 429 out of 500. That's how it works. Number 4, right? Is not high school graduate, but is a homeowner. So is not a high school graduate. Put a little tick mark there. It does not graduate. But is and is a homeowner. It's like but and are kind of the same thing here. So let's work this out here. How many people did not graduate? We'll just use the chart for this. these people did not graduate. These people are homeowners. Okay? So we need homeowners and did not graduate. That's just 119 out of 500. You could use the formula and do it the long way. You could use the formula for intersection, but you don't have to. In this case, you plug it in your calculator, that's what you get. Okay, a couple more examples, and we'll be done. This is the longest lesson ever. 2 dice are rolled. What is the probability that the sum of 7 occurs 4 times in a row? 2 dice are rolled. What is the probability that the sum of 7 occurs 4 times in a row? Alright. So, let's think about how you can get a 7. You can roll a 1, a 2, a 3, a 4, a 5, and a 6 on a dice. You could also, on your second roll. So what we need to do is we need to look at the sample space of all possible outcomes for rolling a dice. You can roll your dice and get that. You can roll a dice and get that. So what is the sum? So if I roll a 1 and a 1, I sum to 2. If I roll a 1 and a 2, I sum to 3. If I roll a 1 and a 3, I sum to 4. If I roll a 2 and a 1, if I roll a 2 and a 2, if I roll a 2 and a 3, and so forth, and so on, and I roll a 3 and a 1. Hopefully you see the pattern right now. What I'm doing is I'm getting the sample space. These are all possible outcomes of rolling 2 dice. Alright, so of all possible outcomes of sums, how many were 7s? 1, 2, 3, 4, 5, 6 out of 36 total outcomes. So 2 die are rolled. What's the probability of 1 6? Sorry, the probability of a 7 sum is 6 out of 36, which is 1 out of 6. What's the probability of a 7 and a 7 and a 7 and a 7 and a 7? How many times? 1, 2, 3, 4, 5. Oh, 4 times in a row. Because these are independent events, rolling 1 7 does not affect rolling another 7. All you do is just multiply this out. Probability of 1 7 is a 6. Probability of another 7 is a 6. A 6th and a 6th. Or you could do a 6 raised to the 4th power, which gives you 0.001. Roughly, rounded. Okay, rounded answer. 0.001. So you have about a 0.1% chance of having a 7 sum 4 times in a row. Very small chance of that happening. 6. Study shows that 63% of Harvard students read Time magazine. We'll just write that down like that. The probability 51% read U.S. News and World Report. I'll just call that U for U.S. News and World Report. 24% read both. So both. We're talking about overlap. What is the probability a student reads either? So I'm going to use the U for union. Either means union. So what I can do here is I can do the probability of this would be the probability of Time plus the probability of U.S. News and World Report minus the overlap Time and U.S. News and World Report. So the probability time is 0.63, that is 0.51, and that's 0.24, for a total of 0.90 something. Let me add that up. Can't read my own writing. 0.90. Just 0.90. There we go. Duh. That's the answer to that question. So in this case, the formula was really the only way to go here. The formula was the way to go. So pause and look at that formula. So we have a formula for and, we have a formula for or, we have a formula for given or conditional stuff. Let's do one more example. The probability of a Chicago commuter bus will break down is 0.12. So I'm going to call that B for breakdown. Like that. Probability of commuter bus train. We got bus and train. So here we go. Probability of bus will break down is 0.12. Probability that a train will break down is 0.07. If the probability that both break down, so both a train and a bus break down, is 0.02, there's your overlap. So that's a bad day. 2% of the time the train and the bus are broken down. What is the probability that there will be no breakdowns on either system? So before I figure this out, let's find the probability that there will be a breakdown on one of the systems. So I'm going to do the union. Once again, the formula is good here. This is the formula for a union. Which is 0.17. Okay, so now let's interpret what we just found here. We found that the probability of a breakdown on a train or a bus, or both, a train or a bus, so something's broken down, is 17%. The question is, what's the probability there would be no breakdowns? So if the probability that there be something, the probability that something's broke is 0.17. The probability that nothing is broke is the opposite of that. 0.83. Wow. It was a lot longer than I thought it'd be. So I probably won't make you do all this tonight. So, with that said, you do have an assignment. This assignment is not necessarily over this back page. I kind of got into future stuff, which is the next assignment. So, probably won't watch all these videos, but this is your homework. Go ahead and take care of that. That'll be due at the end of next class.